Do you know what happens to metal when it is shaped by power? This question from Magneto resonates closer to reality than we imagine. What if I told you that sound frequencies can bend metal, imitating the power we thought was just fiction? Science of sound is more than just vibrations that travel through the air. Specific frequencies have the power to interact with matter in surprising ways. From resonance that can destroy a bridge, to experiments that show sand forming complex patterns under the influence of sound waves. The potential is vast and still largely untapped. But how can these invisible waves actually bend metal? And what are the implications of this discovery for the future of technology and engineering? In this video, we'll dive into the physics behind sound frequencies and explore experiments that challenge our perception of reality. Let's find out how science is beginning to understand and even control these invisible forces. Prepare for an exploration that connects science fiction with real science, revealing a world where sound may be one of the most powerful and transformative forces we know. Since ancient times, sound has fascinated humanity. Ancient civilizations already explored its properties, using it in rituals and constructions. But it was only in the 17th century that scientists began to unravel the mysteries of sound. Robert Hooke, for example, was one of the first to observe that vibrations could create visible patterns on surfaces. This planted the seed for the study of resonance. Fast forward to the 19th century. German physicist Ernst Chladni revealed how sound can shape matter. His experiments with metal plates covered in sand showed that when a violin bow was passed along the edges, the sand formed geometric patterns. These patterns, now known as Chladni figures, highlighted the tangible impact of sound waves. But what makes the sound so powerful? The answer lies in resonance. When a frequency matches the natural frequency of an object, it can amplify vibrations, leading to surprising effects. This was dramatically demonstrated in 1940 when the Tacoma Narrows Bridge in the United States collapsed due to winds that induced a catastrophic resonance. These early discoveries paved the way for a new understanding of sound, but as we explore deeper, we realize that the potential of sound goes beyond the imaginable, promising not only wonders, but also challenges. Since ancient times, sound has fascinated humanity. Civilizations, such as the Egyptians and Greeks, already explored its properties, using it in religious rituals and even in architecture. The Greeks, for example, studied acoustics in theaters, seeking perfection in sound propagation. In the 17th century, the science of sound began to take shape. Robert Hooke, one of the first to investigate the properties of vibrations, observed that sound could create visible patterns on surfaces, like vibrating strings. This planted the seed for the study of resonance, a phenomenon that would become central to understanding the power of sound. Fast forward to the 19th century, German physicist Ernst Chladni made revolutionary discoveries. In his experiments, he spread sand over metal plates and passed a violin bow along the edges. The sand then formed complex geometric patterns, known today as Chladni figures. These patterns were visual proof that sound could shape matter in surprising ways. But what makes the sound so powerful? The answer lies in resonance. When a frequency matches the natural frequency of an object, it can amplify vibrations, leading to dramatic effects. This was demonstrated spectacularly in 1940, when the Tacoma Narrows Bridge in the United States collapsed. Constant winds induced a resonance that made the structure oscillate violently until it collapsed. These early discoveries paved the way for a new understanding of sound. Resonance was not just a scientific curiosity, it was a force that could be both creative and destructive. Scientists began exploring how sound frequencies could be used to manipulate matter at deeper levels. In the 20th century, sound research expanded to include cymatics, the study of visible sound waves. Researchers like Ernst Chladni showed that sound could organize particles into complex, beautiful patterns. These studies not only amazed the public, but also inspired new technological applications. As science advanced, it became clear that the potential of sound went beyond what had been imagined. It promised not only technological marvels, but also raised ethical questions and challenges about its use and control. Sound, which had always been around us, was beginning to be seen as one of the most intriguing and powerful forces in nature. As the 20th century progressed, the understanding of sound and its capabilities began to touch unexpected areas of science. Cymatics, led by Ernst Chladni, not only demonstrated the potential of sound to create visible patterns, but also suggested that these vibrations could influence biological processes. Chladni showed that different frequencies could change the shape of fluids and particles, creating figures that seemed almost organic in their complexity. Meanwhile, in physics, the study of sound waves has led to significant advances in ultrasound technology. Originally developed for military purposes, this technology has found applications in medicine, allowing doctors to view the inside of the human body without the need for invasive surgery. Sound waves, invisible and silent, have become a crucial tool for medical diagnoses, demonstrating once again their transformative power. Furthermore, music, one of the oldest forms of sound manipulation, began to be studied for its therapeutic properties. Research revealed that certain frequencies and rhythms could influence mood and even mental health, leading to the development of sound therapies. This intersection between science and art highlighted sound not just as a physical phenomenon, but as a force capable of touching the body and mind. But as these discoveries accumulated, challenges and controversies also emerged. What would happen if sound frequencies were used to manipulate materials on even larger scales? Could we one day bend metal with sound, like Magneto's fictional powers? And what would be the ethical and practical implications of such a capability? These questions began to attract the interest of engineers and scientists around the world. Research labs have focused on how to control and direct sound waves for industrial applications, from manipulating materials to creating new forms of energy. Sound, which for so long had been seen solely as a tool of communication and art, was being reimagined as a force of engineering and innovation. However, with this potential came responsibility. Like any powerful technology, the use of sound to manipulate matter raised concerns about safety and control. Scientists began exploring the ethical limits of what could be done with sound frequencies, debating how to ensure these capabilities were used for the good of humanity. Thus, the study of sound evolved from a scientific curiosity to a frontier of technological and philosophical innovation. Resonance, which had once destroyed a bridge, now promised to build new realities. But, as always, the real question remained: how far can we go before sound reveals all of its hidden power? As scientists and engineers explored the practical applications of sound, society began to realize the cultural and philosophical impact of these discoveries. The idea that something as common and seemingly harmless as sound could have such vast, transformative power challenged our understanding of reality. The implications were profound. If sound could shape matter, what else could it do? This question was not only scientific, but also philosophical. It forced us to reconsider the role of sound in our lives and in the universe. But, as with any significant advance, there were challenges and controversies. The potential to manipulate matter with sound raised questions about control and safety. Who would have access to this technology, and how to ensure that it was used ethically and responsibly? These questions lead us to the successes and innovations that emerged as the science of sound advanced, discoveries that not only expanded our knowledge, but also opened new technological frontiers. However, as we will see, the path to innovation is rarely linear and devoid of conflict. As discoveries in the field of sound frequencies advanced, scientists' imagination had no limits. Laboratories around the world have begun exploring how sound could be used to create new materials and even new forms of energy. One of the most intriguing innovations was the use of sound waves to manipulate microscale liquids. a technique that promised to revolutionize the manufacturing of electronic and biomedical components. Technology. Companies have also begun investing in research into how sound could improve energy efficiency. By exploring the ability of sound waves to transfer energy without direct contact, engineers envisioned a future where devices could be charged remotely, just through vibrations in the air. In the healthcare field, the use of sound for medical treatments has advanced rapidly. In addition to ultrasound, new techniques have emerged, using sound frequencies to promote cell regeneration and accelerate tissue healing. These advances have not only improved patients' quality of life, but also reduced the need for invasive procedures. But as with any growing field, successes have come with challenges. Tuning frequencies for specific applications required a level of precision that was just beginning to be achieved. Furthermore, the ethical implications of using sound and material manipulations raised questions about safety and control. While the potential of sound frequencies seemed limitless, the responsibility for their use became increasingly clear. The innovations were just beginning to show their true impact, and the world watched with a mixture of awe and caution. But as we will see, not all success stories are without controversy. As research advanced, innovations emerged that captured the imagination of scientists and engineers. One of the most notable advances was the development of acoustic levitation technologies. Using sound waves, researchers were able to suspend small particles in the air, creating the illusion that they were defying gravity. This technique not only fascinated the public, but also opened doors to industrial applications, such as the precise manipulation of materials without physical contact. Furthermore, cymatics, the study of visible sound waves, continued to evolve. Artists and scientists collaborated to create visual and auditory experiences that dazzled and educated. Interactive exhibits allowed the public to see in real time how sound frequencies could create complex and beautiful patterns, connecting art and science in innovative ways. In medicine, ultrasound, already widely used for diagnosis, began to be explored for therapeutic treatments. Specific frequencies have been used to destroy cancer cells, offering a less invasive alternative to traditional treatments. This medical application of sound has demonstrated its potential to not only diagnose, but also heal. But perhaps the most surprising innovation came from the area of materials. Researchers began experimenting with sound frequencies to alter the properties of metals and other solids. Although still in the experimental stage, these studies suggested the possibility of shaping materials with acoustic precision, an idea that seems straight out of the pages of science fiction. These innovations have not come without challenges. Adjusting frequencies to obtain desired results required extreme precision and a deep understanding of material properties. Furthermore, the potential for misuse or unintended consequences raised ethical and safety concerns. While the science of sound promised wonders, it also demanded responsibility. Innovations were just beginning to show their true potential, and the world watched with both anticipation and caution. But as with any rapidly developing field, not everything was positive, and the journey was far from smooth. Sound frequencies have always fascinated humanity, but it was only in the 20th century that we began to understand their true potential. In the 1960s, the development of acoustic levitation technologies brought a new perspective on sound. Inspired by Ernst Chladni's 19th century experiments, where geometric patterns were formed by sound vibrations, NASA scientists began exploring how sound waves could be used to manipulate particles in microgravity environments. This research not only fascinated the public, but also opened doors to industrial applications, enabling the precise manipulation of materials without physical contact. Cymatics, popularized by Hans Jenny in the 1960s, revealed the hidden beauty of sound waves. Jenny demonstrated how different frequencies could create complex patterns in liquids and powders, connecting art and science in innovative ways. These discoveries inspired artists and scientists to collaborate, creating interactive exhibits, where the public could see in real time how sound shaped matter. This fusion of art and science not only captivated audiences, but also challenged the limits of what was considered possible in the world of performance and installation, art. In medicine, ultrasound has emerged as a revolutionary technology. Since its introduction in the 1950s, ultrasound has transformed medical diagnosis, allowing doctors to view the inside of the human body, without the need for invasive surgery. In the 1980s, researchers began exploring the use of sound frequencies for therapeutic treatments. Studies showed that certain frequencies could destroy cancer cells, offering a less invasive alternative to traditional treatments and demonstrating the potential of sound to not only diagnose but also heal. Innovation in the area of materials has brought surprising discoveries. In the 1990s, scientists began experimenting with sound frequencies to alter the properties of metals and other solids. Although still in the experimental stage, these studies suggested the possibility of shaping materials with acoustic precision. This idea, which seemed straight out of the pages of science fiction, began to gain traction, with laboratories around the world dedicated to exploring its possibilities. Technology companies invested heavily in research and development to explore how sound could revolutionize communication and entertainment. In the 2000s, 3D sound technologies emerged, promising listening experiences that put the listener at the center of the action, whether in a movie or a video game. This innovation has not only transformed the way we consume media, but also opened up new possibilities for virtual and augmented reality. In addition to practical applications, sound frequencies began to inspire new forms of art and expression. Composers and sound artists explored how different frequencies could evoke specific emotions, creating immersive experiences that went beyond traditional music. This fusion of art and science not only captivated audiences, but also challenged the limits of what was considered possible in the world of performance and installation art. However, as these innovations flourished, questions arose about the impact of sound frequencies on human health and the environment. Studies have begun to investigate how prolonged exposure to certain frequencies could affect physical and mental well-being, raising concerns about the safety of new sound technologies. Research in the 2010s highlighted the need for regulation and control, especially in urban environments, where noise pollution was becoming a growing concern. These discoveries, both promising and worrying, paved the way for a new chapter in the history of sound frequencies. A chapter that not only celebrates successes and innovations, but also confronts the controversies and challenges that come with the power to manipulate sound at such profound levels. As we move forward, the responsibility to ensure these technologies are used ethically and safely becomes increasingly pressing. Sound, an invisible and often underestimated force, has proven to be one of the most powerful tools at humanity's disposal. Its applications, ranging from art to medicine, continue to expand our understanding of the world and ourselves. But like any powerful tool, sound also requires caution and consideration, reminding us that with great power comes great responsibility. As research continued to advance, sound frequencies began to be seen as a solution to environmental challenges. Scientists have explored how sound could be used to clean up oil spills, using acoustic waves to separate and collect contaminants from water. This method, still under development, promised to be a more ecological and efficient alternative compared to traditional methods. In agriculture, sound frequencies began to be applied to stimulate plant growth. Studies showed that certain frequencies could increase the germination rate and improve the plant's resistance to pests. This innovative approach offered a sustainable way to increase agricultural productivity without relying on harmful chemicals. Furthermore, sound began to play a crucial role in space exploration. NASA researchers investigated how sound waves could be used to detect and analyze the composition of asteroids and other celestial bodies. This non-invasive technique offered a new way to study space, allowing scientists to obtain valuable data without the need for risky manned missions. In the field of psychology, sound therapy has gained popularity as a complementary approach to treating conditions such as anxiety and depression. Specific frequencies have been used to induce states of deep relaxation, helping patients achieve mental and emotional balance. This practice, although ancient in some cultures, has begun to gain scientific recognition, with clinical studies supporting its effectiveness. As these applications expanded, collaboration across disciplines became essential. Engineers, artists, doctors, and scientists worked together to explore new frontiers, each bringing their expertise to discover how sound could be harnessed in innovative and beneficial ways. However, with these opportunities came new challenges. The need for safety regulations and standards has become more evident, especially in industrial and medical applications. The potential for misuse or unintended consequences required a careful and ethical approach, ensuring that innovations were developed responsibly. Sound, a force that has always been present in our lives, continued to surprise and inspire. Its capabilities, still largely untapped, promise to transform our world in ways we have only begun to imagine. But, as always, the future of sound depended on our ability to balance innovation with responsibility, ensuring its power was used for the benefit of all. Despite impressive advances, the use of sound frequencies has not been without controversy. In the 1980s, studies began to indicate that prolonged exposure to certain frequencies could cause discomfort and even hearing damage. This led to debates about regulating the use of sound in urban and industrial environments, especially in densely populated cities, where noise pollution was becoming a growing problem. The manipulation of materials through sound has raised significant ethical questions. In the 1990s, when researchers began demonstrating the ability to bend metals using specific frequencies, concerns arose about safety and control. Who would have access to this technology, and how to ensure that it was not used for harmful purposes? These questions became central in discussions about the responsibility of the scientists and engineers who developed these innovations. The controversy also extended to the field of medicine. In the 2000s, while the therapeutic use of sound showed benefits, critics pointed out the lack of regulation and standardization. Some treatments were considered too experimental, with efficacy and safety not yet proven. This has sparked a heated debate among healthcare professionals and researchers, highlighting the need for more clinical studies and clear guidelines. In the art world, sound frequencies used in interactive installations have raised concerns about accessibility and inclusivity. Certain frequencies could be uncomfortable or even harmful for people with hearing sensitivities. In the 2010s, artists and curators began to rethink the design of their exhibitions to ensure they were safe and enjoyable for all audiences. These controversies were not just limited to health and safety issues. The environmental impact of sound technologies has also been questioned. Research has shown that excessive use of sound frequencies in natural environments could disrupt ecosystems, affecting wildlife and biodiversity. This has led to an urgent call for more sustainable and conscious practices, especially in protected areas and national parks. The debate over sound and its applications has brought to light the need for an open and transparent dialogue between scientists, regulators, and the public. As the potential of sound continued to grow, the responsibility to ensure it was used ethically and safely became increasingly evident. It was a reminder that even the most promising technologies come with challenges that require careful consideration and collective action. Sound frequencies, with their immense potential, continued to capture the world's imagination. But, like any powerful tool, they required a balance between innovation and responsibility. The future of sound depended on our ability to confront these controversies and find solutions that benefited everyone. In recent years, Discussion about the impact of sound frequencies has intensified, especially with the advent of advanced communication technologies. In 2015, the debate over the safety of frequencies used in telecommunications networks, such as 5G, highlighted the need for more research into the long-term effects of these waves on the human body. While some studies suggested that higher frequencies could have negative impacts, others stated that there was no conclusive evidence, leading to a scientific and regulatory impasse. History has also shown how sound has been used in controversial ways in military contexts. During the Cold War, for example, there were rumors that sound frequencies were being explored as non-lethal weapons, capable of disorienting or temporarily incapacitating enemies. Although many of these projects remain classified, they have raised ethical concerns about the use of sound as a tool of control and coercion. Additionally, the use of sound frequencies in advertising and marketing has sparked debates about privacy and manipulation. In the 2000s, companies began experimenting with subliminal sounds to influence consumer behavior, a practice that was quickly criticized by consumer rights advocates and ethicists. In the healthcare field, the use of unconventional sound therapies has continued to divide opinion. While some patients reported significant improvements, the medical community remained skeptical, demanding more robust evidence before widely adopting these practices. This divide highlighted the tension between innovation and scientific evidence, an issue that persists in many areas of alternative medicine. Finally, the environmental impact of sound technologies continued to be a growing concern. In 2018, a study revealed that noise pollution was negatively affecting communication between marine species, leading to a decrease in biodiversity in certain areas. This has led to a global call for stricter regulations on the use of sound in aquatic environments, especially in fishing grounds and shipping lanes. These controversies and challenges highlight the need for a careful balance between exploration and responsibility. As we continue to discover the potential of sound, it is crucial that we do so with deep consideration for the ethical, social, and environmental implications, ensuring that its wonders are accessible and safe for everyone. Let's enrich the final section with historical references. The legacy of sound frequencies is vast and multifaceted, influencing areas ranging from science to art. From Galileo Galilei's discovery of resonance in the 17th century to Ernst Chladni's 18th century experiments that revealed geometric patterns formed by vibrations, sound has shaped our understanding of the world in profound and lasting ways. In science, discoveries about sound frequencies opened new frontiers in physics and engineering. In the 20th century, acoustic levitation developed by NASA demonstrated how sound could manipulate objects in microgravity. This ability to manipulate materials with acoustic precision continues to inspire innovation, promising advances in manufacturing and construction technologies. In medicine, the use of sound has revolutionized diagnoses and treatments. From the advent of ultrasound in the 1950s, which transformed the way we visualize the inside of the human body, to the therapeutic treatments developed in the following decades, sound has improved the quality of life for millions of people. These innovations highlight the role of sound as a tool for healing and well-being. Culturally, sound continues to inspire and challenge artists and musicians. In the 1960s, Ernst Chladni popularized cymatics, revealing how frequencies could create visible patterns, inspiring new forms of sound art. Cymatics and other art forms offer new ways to experience and understand the world, connecting science and creativity in innovative ways. However, the legacy of sound also brings responsibilities. The 1980s controversies over urban noise pollution and the 2000s debates over the use of frequencies in telecommunications highlight the need for regulation and ethics in the development of new technologies. Ensuring that sound is used safely and beneficially is an ongoing task that requires collaboration between scientists, policymakers, and society. Exploring the limitless potential of sound frequencies raises fundamental questions. How far can we go before sound reveals all of its hidden power? Are we ready to deal with the ethical implications of manipulating matter with invisible waves? Sound, in its essence, connects and transforms. But how do we ensure that its capabilities are used for the benefit of all? As we continue to discover new applications, it is crucial to reflect on how to balance innovation and responsibility. Are we prepared for a future where sound not only communicates, but also builds and heals? And, most importantly, how can we ensure that this powerful force remains an ally, not a threat, on our path to progress?